There's a problem in there. Good morning, all of you. We'll continue with the thermal expansion of solid, that one. Yesterday, we had a theoretical discussion. So today, let me take you to the problems related to different types of the application, that one. Almost all mechanics you can see here now. There's a one nice topic, that one. So if you look at the material and the books now, different types of numerical soluble. I'll try to cover maximum. You should also try to work out. Almost with all topics, this particular expansion of solids is related. Do pick up numericals of that kind. Okay, yesterday we have seen it was yesterday what we have seen is like the simple pendulum. No, what was the problem we had? The simple pendulum, what happened as the temperature varies, so it may gain time or lose time. It may gain time or lose time. So how to overcome this? So I will bring a compensated pendulum. So this is called like a compensated pendulum, that one. So what is this compensated pendulum? How it will be? So it consists of like two light rods. Wait, I'll bring triangle. This will be. We have triangle. Okay, this is the the length of this one. So here I'll suspend a bob. I think problem will be solved. No, this with the bob. And this will be the length L. So what is the time period of this one? And it will be suspended about this particular point. So what is the effective length of the pendulum? It is equal to L. What is the time period of this pendulum? T equal to 2 pi root of L by J. So these are the rods. So what we have is the rod A, B, C. So AB is equal to, okay, this length is L1 by 2, L1 by 2. This is L2, this is L2. Alpha of materials are different. Alpha 1, this alpha 1. Now, if I increase the temperature, what will happen to rod AB and like a AC and BC? They will expand. But if I can maintain that L constant, I think problem solved. Able to analyze? So what is our main purpose? The time period of pendulum depends on the L length. Anyway, G what happens? G depends on the gravity, so that will not have any impact here. So if I increase the temperature, if the length remains same, the problem will be solved, L. But the rod will expand. They will expand here. So how the possible diagram will be? So it is hinged about this particular point. So it will oscillate about this point too. So the distance OC must remain constant. That's what I should plan here. So the compensated pendulum, let's get into the mathematics of this. So these are the various, so you can like just go back to 50, 60 years, just even in my, when I was very young, no, we didn't have digital clocks. We have to depend only on what, like the pendulums only. If you go any home, no, the pendulum clocks were there, and there was a lot of problem is there. So they have constructed almost around 250 different types of pendulum clocks were available. Now, because of digital technology, all what happened, and there used to be always a problem. So many moving parts. So we have simplified everything. We brought a digital technology. So just go back 50 years, 100, 150 years. No, it was a very big industry, the clock industry. That one. So now, okay, we have totally overcome all that particular problems. Now, 250 different types of pendulums are there. I'm discussing this is a second one. Okay, have an idea like this. Huh? Okay, now as it expands, so we know that, so due to thermal expansion, there'll be expansion like this. But what will happen to this length L? It should remain constant, or call Y or whatever you wish. So let it be this one. So what is this part? So shall we call this is delta L1 by 2, and it has expanded here. If you see, this is delta L2. Yeah, we have like this. Okay, how to manage this particular problem? Let me take this triangle OCB. In the triangle OCB, what we can write, CB square equal to OC square plus OB square. CB square is what? L2 square. OC is what? L square. What is OB? L1 by 2 whole square. Or this will become L2 square, L square, L1 square by 4. Now, as I rise the temperature, definitely both the rods will expand. Both the rod A, like AB and AC will expand. These rods will expand. So what is L2? L2 is a constant or variable? It's a variable. Let me differentiate this. So 2L2 delta L2. L must be constant, no? Or time being, you write it 2L delta L plus 2L1 delta L1 by 4. So what should be the condition? Delta L should be 0. Then only what will happen? L will be constant. So what do we get this one now? 2L2 delta L2 is equal to L1 delta L1 by 2. So I want certain conditions. What are the conditions that will be? Okay, let me do like this. L2 by L1 is equal to delta L1 by 4 delta L2. So what is delta L1? L1 alpha 1 delta theta. Change in temperature. So what is delta L2? L2 alpha 2 delta 2. Delta theta, change in temperature, that will get cancelled out. So therefore what we get is L2 square by L1 square is equal to alpha 1 by 4 alpha 2. It is L2, huh? L2 by L1 it is, yeah. Okay, this is the condition. This is satisfied, no? The length L will not change. So therefore, then the pendulum, the time period of pendulum depends on what? Depends on capital L. Okay, like this, what happens? There you do get plenty of conditions, not one, two, plenty of conditions. Okay, there's one example with what I gave, the compensated pendulum. Any other diagram-based questions like this also come, you should stick on to the basic geometry. So another way, don't think that they will not expand. You can see clearly here, both have expansion. So you can see this one here. Both the rods will expand, but this will remain constant. I should write capital L, no change. Okay, let me take to the. Okay, after getting this, so we will take some. I think yesterday we have discussed now with gravity also. In gravity also they can ask you this.